What in the world do chemical engineers do?
Make life-saving medicines accessible to everyone.
Develop and deliver new energy sources safely and responsibly.
Eliminate plastic waste from our oceans.
When it comes to getting things done, chemical engineers have a pretty full to-do list. We do the math, science, and engineering to make medicine accessible, water drinkable, air breathable, the deep thinking to make the environment sustainable, systems affordable, safety reliable. We make discoveries scalable, and the inconceivable feasible. So, what in the world do chemical engineers do? We take things that have never been done and get them done. For good. AICHE, doing a world of good.
Yeah, our program has a proud history to nurture our students' success. Equip our students with lifelong learning experience, as well as their thinking and lifelong learning skills to teach themselves. We are bold in ideas to support our students' dreams and their needs. Our chemical engineering program started in 1926, and at that time, our student chapter was the sixth in the country as part of the American Institute for Chemical Engineers. Our program also offered the first PhD degree to African American female in the field of chemical engineering in the United States. That was awarded in 1972. So you can see our department has a product history, and we are bold to push the limit in the field, in innovation, in everything we do. Our student chapter has won the Outstanding Student Chapter Award for 29 times in the past 30 years. And in the past 12 years, our student team has won National Chemical Engineering Deputy Championship of the American Institute for Chemical Engineering 4 times, as well as the runner-up 4 times in the past 12 years of the competition. No other student chapter won this kind of honors more than once in the US. We are passionate about our students' learning experience and outcome. With personalized education, innovative research labs, and award-winning faculty, we offer our students a rigorous academic environment and a life-changing learning experience. Our medium-sized department ensures the success of our tradition of engaging our undergraduate students and grad students at an intermediate level, while maintaining a strong sense of community throughout their time in our department and the University of Iowa.
Chemical and biochemical engineering at the University of Iowa has worked pretty hard to, has really made a commitment to try to create an environment where everyone in our community feels like they are welcomed and supported. And that runs the gamut in the community, from students, faculty, staff, right? Really everybody. And so we have spent quite a bit of time, particularly with the undergraduate and graduate students, trying to identify the areas that we could really improve the climate and the culture of chemical engineering. So one of the ways that students can get involved is our DEI Student Ambassadors Group. So this is a group of students who have volunteered to be to be an ambassador for chemical engineering. And part of their role is to be able to ask students, connect with students within their cohorts, ask questions, see how things are going. Again, helping to make people feel like they are welcomed and that they have people they can talk to, but also that they can give feedback to us that is representative of the groups that they are a part of. So that has been a really nice add that, again, the DEI Council is the one who kind of focused on the development of that program. My favorite thing about the chemical engineering department, and really one of the things that drove me to become a faculty member here, was the people. I really felt that people cared about other people. The faculty actually cared about the students, wanted to see them succeed, and spent a lot of time trying to help students in any way that they can.
Here at the Teaching Lab, we have 4 different laboratories that the students will go through. In all our laboratories, we're really trying to make all the machines very visual, very hands-on, very transparent. So even on things like this, a white film evaporator, you can see the inner workings and see how the mechanisms are moving around and how the chemicals go through the process. This can be used for many different things different people may know about. Food products, we use this a lot. We use it a lot in cosmetics, in perfume oils, and several other industrial processes. So all our labs, we have very visual, hands-on components. We're trying to make them fun and exciting for all the students. We of course try to keep everything very safe. So another thing that chemical engineers do is we work a lot with chemicals, and those chemicals have the potential to have catastrophic problems. So we teach not only the engineers how to keep themselves safe, but how to keep the community safe. So doing that, we do a lot of experiments. We do chemical spill cleanups. If you spill a chemical, how can you clean it up safely? We also are doing experiments where we make polymer hydrogel films where we can remove pollutants from the water. Dust explosions are a big one here in Iowa. We have a lot of grain bins and they can form dust, and that dust can explode. Even though we would think corn or flour would be a nice, safe substance, it can have dangers too. So we have a lab where we study those dust explosions and what kind of conditions can make a dust explosion, and more importantly, how to prevent that from happening.
There are many focus areas of research in the CBE department at Iowa, including weather, climate, atmospheric science, advanced functional materials, drug design, clean energy, and machine learning and simulation. What is machine learning, right? So in engineering and physical sciences, we benefit greatly from the work of scientists in previous generations that have developed models which we can use for understanding. These models are successful because they take equations about how we know that mass and energy are transferred and transformed, and make some simplifying assumptions so that we can solve these equations exactly and use these solutions to understand our physical world. What machine learning does is it presumes to know very little about the physics behind phenomena that we observe, but simply collects a lot of observations, right? So machine learning and physics-based learning are trying to solve the same kinds of problems, but with different sets of tools, right? And so what this looks like is that within our department and other engineering departments, we're applying these tool sets of machine learning together with large sets of data, either collected experimentally or from simulations, and try to learn something about the physical phenomena that generated these data, and then use these machine learning models, which are often much faster to evaluate than the physics-based models, to accelerate the pace at which we can perform discoveries of new materials, or simulate the physics of, say, the processes that happen in the atmosphere.
So if I could give one piece of advice to the students in chemical engineering, I would say it's to get involved. Get involved in any way you can, whatever your interests are, try new things out, but just get involved. It'll help you in feeling that sense of community. It'll help you build a community of people that can give you guidance likely for the rest of your life, certainly far into your